Do you get double pay for doing two stops?
What? I'm sorry, do I what?
Yeah, we gave him 1,000% raise.
1,000%.
Times zero, it's still zero.
That's right.
1,000,000%.
Yeah.
With 100% certainty. Okay, so welcome. Most of you know me. I'm Don from Sandia. I'm also the chair this year because Bob has
Abdicated?
Put me down.
ran and hid. But I want to thank Bob for his service last year. I wasn't here.
Yay,
I wasn't here the last meeting, but Bob did a great job. He's been one of the best leaders we've had in a long time. And so it's going to be a tough act to follow, and I'm not even going to try and keep up with his standards. But I'll try and stay at the 50th percentile. That'll be good enough for me. All right, we're going to talk about creating predictive models from web-based applets. What does that mean? If you don't know, don't worry about it. I'll give you a little intro of what I'm talking about there, and then we'll actually do some fun stuff. So, have you ever been on a website where you enter various variables and then it spits out a number? For example, one that you may have used is real age. That's a fun one, actually.
Yeah, what's going around?
Real age, you type in a bunch of stuff and it tells you how old you really are. You would be very young, for example, because you exercise, you eat right, you're not having any of this dessert, you didn't do the buffet, you don't smoke 3 packs a day, you're down to 2 now.
A cigar.
But you input all these variables, including what weight and height, and it tells you, I think what it does is it says, you're at the 50th percentile on life expectancy for this particular age based on all these factors. It tells you about what your equivalent age is. There are these other things, heart attack risk calculators. We're going to do one of these. And then there are some other links on probability of a recession in the next 12 months, predicting how long your marriage will last based on some other factors. This is all on. This is Ian Ayers. He was actually at the Jump conference. I met him. He was the author of Super Crunches, which is a pretty cool book. If you are like nerdy books like I do, then that's a good one to read. Have you read that one, Rick?
Yeah.
Rick's like me. He likes the nerdy books too. Oh, sorry.
Nobody's like me.
That's good.
That's exactly.
Somebody sent me an email today and asked if I was normal, and I said, no, I'm white. She actually understood it too. It was
You didn't say
phenomenal.
50% of the time.
That's good.
So here are some screenshots from some of those calculators. This is the heart disease risk calculator. This is one we're going to actually do. I think it actually may be this website. A lot of them use the same model. And so when we put stuff in and we get a number out, well, what does that mean? What if I said I smoke or versus I don't smoke? How does that change it? So you have to do another what if scenario, plug in the numbers and say, oh, I see it changed it by 3%, so that must be what it is. What if I said I don't take blood pressure medication? What if later on I do? What's that going to do to my life expectancy? So you go through and you change that little radio button to the other one and see how it changes it. Well, you can take all of these things and you can reverse engineer that. And I'm going to show you how to do that. And then we basically come up with a model. And for any of these factors, we just move this in Jump. We're going to move a little slider button for any setting, and it'll tell us our predicted age, or our heart disease risk, I'm sorry. So, and this is what I just mentioned, the problem with these calculators are that we have to run them over and over and over again if we want to see, well, what about this? What about that? So it would be nice if we had this sort of tool where we can just, for age, we just slide the bar, and for smoking, we just move it from yes to no, and we can see what it does to the prediction all in one simple thing where I don't have to keep going through that web page every time. In fact, we could even see the interaction. For example, if I look at age versus probability of a heart attack, is that different for males and females? Is that different? So we can determine that with this model too. So I'm going to do this in Jump. This is a talk that I actually gave at the Jump conference, but I thought it would be a good topic for the quality folks as well, because a lot of times we do these applets for our customers, we may be doing surveys, for example. Well, can we take that survey data and create a model, a prediction model from that? We could. And then I'm going to do some simulations too to show you how you really need to know the uncertainties of your predictions as well. So we will do a custom design for this particular website. Let me see if this link, I'm going to exit out of this and see if I have, oh, I'm not sure I have internet access here yet. I don't really need the internet to show you this, but if I do, I may be able to jump to the web page. Did it work? Okay, let me do this real quick. I may need a secret code.
You just have to agree.
They just say accept, okay.
Yeah.
Oh, come on. I don't have to do that, do I? She already knows me. I think I have to do at least this. Okay, I'm online, so it says. So let's go back here. Let's see. Okay. Yeah, so here's the tool. Let me see if I can get it on the screen on this low resolution projector. So risk assessment tool for estimating your 10-year risk of having a heart attack. So for me, let's just do it. I am, oh, 5, I meant to type a 3. Okay, well, let's just say, that was a typo, so let's just say over 52, much older than I really am. And male, and my total cholesterol is about that before this meal. After that, it's about 280. HDL, I know, is about 43. I don't smoke yet, but I keep.
You're still talking.
There are many things that will drive me to smoking. Systolic blood pressure is around 118, and I'm not on medication yet. So my risk of a heart attack is about 4%. See that?
Wow.
In the next 10 years, I have about a 1 in 25% chance. Well, you know. So let's go back to the presentation. But now, what if I wanted to change something on that? What if I said, well, what if I did take blood pressure medication? How would it change that? And I got to go through that whole thing all over again. But we're going to do, we're going to create an experiment, and we're going to set up a designed experiment where we're varying all of those factors simultaneously. How many of you have had design experiments trained? Where ASQ, a lot of them, most of you should. DOE. So we're going to do a DOE on that applet, and then we're going to reverse engineer it. So I asked for volunteers. If anybody wants to give their numbers, I went ahead and did it. I'll spare you. But if anybody else wants to do that later, there'll be more opportunity. All right. So I won't talk about this too much. This is essentially a design that I created. With Jump, all I had to tell it was, I want these variables, and I want them at these levels. So I had to manually type in age, gender, total cholesterol, HDL, smoker, systolic blood pressure, and medication. Then I had to tell it, is it categorical or continuous? And then I had to tell it my low and high values. And I said, design me the experiment. And so Jump does that for me, and it comes up with, okay, for run number 1, you are a 30-year-old male with 130 cholesterol, your HDL is 45, you're not a smoker, blah, blah, blah. And I would actually have to run that and then put in the number that was spit out from the app. And I ran all of these experiments, and I spit out the risk. Okay, I had to do it 39 times. Well, it's a lot easier to do the what ifs one at a time. But once I have this, then everybody could have this model. And nobody would ever have to plug the numbers into that. You have the model, and you move the sliders, and it tells you your risk. Why not just put this slider, this model on the web page instead of these fill in the blank?
You have to teach it somehow the importance of these different variables.
No, I'm going to figure out what the importance is by reverse engineering.
Oh, so you'd have these, so you collect these data, these are different data samples. You plug them into the engine on
Yes.
their system, it gives you that value, that lets you reverse it.
Yes, that's exactly what we're
Now,
doing. Yeah.
And we have to have that, yes, don't put in the numbers because we only have 3 years of math instead of 4 in the high schools now.
I'm sorry, say that again.
Well, we have to do that because we only have 3 years of math in the high schools and not 4.
Oh, okay. Is that all they have to do is 3 years of that?
The new plan.
So this is just a diagram of all of these variables and the two-factor interactions as well, how they correlate to each other. When you design an experiment, remember you want everything to be orthogonal. You don't want anything to be correlated to anything else, because then if you see a signal, you don't know which variable caused that. If I'm trying to predict my weight based on height and age, they're both going to correlate. So which one is it that you want variables that are not correlated to each other? And this shows the correlation using design of experiments, that the correlation amongst all these variables is near 0. Blue is 0, red means they're correlated. This diagonal is just all of the variables correlated to themselves perfectly with non-correlation. So this is an example response of one of the